Hey, class. Welcome to an example problem for Unit 4.4. In Unit 4.4, we are talking about moments of couples. Um, and so we're going to learn about what a couple is. Um, and I've chosen to do problem 4-89 in the 13th edition of the book. Here's the picture. We kind of have this pipe thing going, and there's a couple of forces acting on there. And I've redrawn it simplified on the board. So we have this pipe. It goes in the x direction and it goes up at an angle in the y and z direction, has another member in the x direction. And acting on this pipe, there are four forces. There's this force, F1, that's going 50, has a magnitude of 50 newtons going in the positive x direction. This force is also 50 newtons going in the negative x direction. And there's this force that's going down 35 newtons, 35 newtons in the z direction. And this force that's doing the opposite, it's going up 35 in the z direction. So a couple moment, a couple is when you have kind of like this situation, you have forces that are exactly opposite of each other. So if you were to do the sum of the forces, they're going to just cancel each other right out. But they do cause a twist, right? Since they're acting, it's like if you had two hands on the edge of a steering wheel and you do this, right? Your hands are going, one hand's going down, one hand's going up. They're causing a twist, but they're not, ripping the steering wheel out of its socket. And couples have some interesting properties. One of the most interesting is that when you're solving for the moment caused by a couple, you can pick any point that you desire anywhere in the system, and you will get the same answer, right? Before, we've always had a specific, we were finding the moment about a point caused by a force. And that moment would change based on what, if you picked a different point, you're going to get a different moment. That's not the case with couples. Couples, if I were, we're trying to solve the moment caused by these forces F1s, I could pick here, I could pick here, I could pick here, I could pick here. It doesn't matter. I'm going to get the same moment. So it's sort of it's just a pure moment. It's a moment that can be applied anywhere. It's not position dependent, I guess, is what I'm trying to say. So in this problem, we have these two couple moments. And what we're trying to find is the resultant moment caused by the two couples. Couples, of course, have led to the classic statics joke. If you're ever looking for a good pickup line, just say, hey, honey, do you have a moment? Because I think we'd make a great couple. And then you will sure to not get a date because they'll just laugh at you and walk away or think you're weird. So how do we go about this? So like I said, we don't have to find it about a moment caused by a couple about any specific point. So we can pick the point that's the most convenient. And in most cases, the point that's most convenient is a point where we get to cancel out stuff. So usually the easiest thing to do is to pick a point that is on the line of action of one of your forces, and then use that as your position vector from there to there, right? So like, I'll demonstrate. So we're going to call this point A down here. This point B, and this point C. So let's start with finding the moment caused by force F1, this 50 newton in the x direction. So to do that, I'm going to find the position vector from either A to C or C to A. I'm going to do A to C. So when I do that, I get that it is let's see, 250 in the x direction. In the y direction, it is minus 400 cosine 30. And in the z direction, it is plus 100 sine theta. And so if I simplify that down, I get the RAC equals x minus 346.4 j plus 200 k that. Call that 1. And so if I want to find the moment caused by F1, so say moment 1 is going to be RAC crossed with this F1, which is the negative, because since we're starting at point A, this part, this moment, or this force F1 does not cause a moment about point A. So set that up. So like this. 250 minus 346.4, 200, I get minus 50, 0, 0. This should be a pretty easy one. Solve for. So what that ends looking like? Ends up looking for this. So cover up the x column, that's going to be 0. So 0 minus j, so 250 times 0, okay, 0, and then minus negative 50 times 200, and then for the k, 250 times 0 is 0, minus 1, negative 50 times negative 346. So a lot of negative signs here. It's very important to keep them all straight. And when I do the math on that, I get that my moment 1 negative 10,000 in the y direction minus 17,320 in the k direction. That's within millimeters. So that's not my final answer, but it's one that we're going to come back to. It's going to get us there. So hopefully that makes sense so far. We just picked the most convenient point, and the most convenient point is a point that cancels out one of the forces in the couple. So now we're going to do the same thing for force 2. For that one, right? The most convenient thing to do is pick either to find the moment about point B or about point A. We're going to do point A again, just because it's going to be most convenient. So what we want to find is the position vector from A to B. And position vector from A to B is going to be pretty similar to the position vector from A to C, which is minus the x. So we get minus 346.4 k plus 200 k. That's a good one. So the moment for 2 R A B cross with force 2 and since we're going from A to B, it's we're finding the moment about this point. So this F2 cancels, it goes right through the point. It's not going to cause a moment, so it's this one. So the positive z direction. So set up our cross product. RAB has 0 in the I. negative 346.4 J 200 K, and F2 only has a Z component, so 0, 0, 35. And solve that out. All right, so the I component, we get negative 346.4 times 35 and a 0. For the J components, minus 0 times 0. And then for the K component, it's also 0 times 0, 0 plus 0. So we wind up with just a Z component, 12,124 millimeters. So yeah, the resultant moment is just going to be M1 plus M2. Just going to say 7 2 and 4. And I'll just finish up here. The resultant moment is negative 12, 1, 2, 4, I minus NJ minus 17.32 K and meters. I just went ahead and converted to meters, so we didn't have quite as many digits. And so that's the answer. So overall, pretty simple. With 3D problems, you know, it's still typically going to be easiest, even in a case like this where everything's relatively nice and square, to just use cross products. We could do this without cross products, just taking the x components of forces times the perpendicular components of the distance. So we could take, like, for F1, we could take, okay, it's in the x, so we could just take the force times the z and the y components of the distance and do that like we've done, kind of like what we did in 2D. I don't recommend that typically because it's just going to get more confusing. You can easily mix up your signs, but that's typically the process. So again, the takeaway with moments or with couples is when solving the moment caused by a couple, pick the most convenient point, because no matter what point you pick to take the moment about, you will get the same answer. So pick a point that lets you cancel one of them out, one of the forces out, and you will be in good shape. So hopefully that's helpful. And as always, if you have questions, don't hesitate to reach out to me.